Hi, I'm Todd Cook. Welcome back to the kitchen for another episode of Polymer Club's Ask the Cook. We're here to talk about polymers and polymer application. We help you answer the question, what do you need to know to add polymer skills to your career? Today I want to talk to you about an important aspect of filling an injection molded part. You can vary the input rate of the polymer by changing the speed at which the screw moves forward to accommodate the geometry of the part and get better outcomes. This is called injection profiling. And it's a really interesting thing to think about when you're thinking about the physics of injection molding, so I want to go through it with you. So you can imagine if you are molding a frisbee or a disc, right? You're molding a round object, uniform wall thickness, and you're gating in the center. Then the flow front of the polymer is growing constantly throughout the filling process, getting larger and larger and larger. So to keep the velocities and the associated cooling rates and shear rates consistent throughout the filling process, you might want to profile the injection to go faster and faster and faster throughout the filling process. Now, suppose you're doing something simpler like a piece of trim, long and skinny rectangle, and it's gated at the end. Now you have a flow front that grows initially from the gate and reaches a maximum size very quickly and then runs along the entire length of the part at that size. So there you might want an injection profile that grows initially and then stays quite constant throughout time in order to keep, like I said, the shear rates and the cooling rates for that material consistent. That helps get you a nice flat part and a higher quality part. In the extreme, you might even consider monitoring the pressure through this process and being able to evaluate the growth or shrinkage of the need for that input by using the pressure, and I'll talk about that in another episode. But what's interesting about this is if you have a mold that's complete and you haven't run it before, you can do a short shot sequence. You can simply measure the cross-sectional area of the melt front as it develops through the part and adjust the profile accordingly to keep the velocities constant and get really good molding results. Alternatively, if you don't have the mold, you can do a simulation, and the simulation will show you what happens to that melt front over time as it moves through the part, filling the part. Knowing that injection profiling can help improve part quality and how it impacts the physics of injection molding, that's working knowledge. Just what you get when you watch us here at this community at Polymer Club, Ask the Cook. Don't forget to subscribe, like, turn on notifications, and even share if you appreciate the content. You can follow a link in the description to learn more about Polymer Club and our community and how to get involved. I'm Todd Cook for Polymer Club, Ask the Cook. Thanks for watching.